reacting with oxygen to form CO2. Then the same thing applicable to another carbon in form of graphite with oxygen to form CO2. All these three reactions shows combustion reaction, and they are all exothermic. When you look at the change of enthalpy here, you can see everything is negative. Then also, the heat of combustion is used in calculating the calorific value of a fuel. You can be asked to calculate the calorific value of fuel. If you want to do that, then it is change in enthalpy over the atomic weight or the molecular mass of that particular compound. Now look at this example. Combustion of butane involve minus 2878.8 kilojoule per mole of heat. So its calorific value is, so you want you to calculate the calorific value of combustion of butane, which involves minus 2878.8 kilogram per mole. So in this case here, all you just need to do that minus 28.78.8 kilogram per mole is change in enthalpy. So the value, you divide it by the molecular mass of butane. Your butane is C4H10. So if you calculate the molar mass of C4H10, you get 58. So you just use that to divide it, and you can see your answer here is minus 49.62 kilojoule. Sorry. Okay. Now we have heat of solution. Heat of solution can be defined as the quantity of heat evolved or absorbed when 1 mole of a substance is dissolved completely in large excess of water, so that further dilution of solution does not produce any heat. So the heat evolved or absorbed when you dissolve 1 mole of a solute, 1 mole of a solute in a solvent. The heat evolved or absorbed during that process is called heat of solution. And you can see what we have here. In the case of potassium chloride, you can see that what we have there is endothermic, and during the dissolution of hydrogen chloride in water to form hydrochloric acid, that particular reaction is exothermic. Then we also have heat of neutralization. I want to believe by now you know what we call neutralization reaction. So now the quantity of heat evolved when one equivalent of an acid is completely neutralized by equivalent mole of or number of a base. Neutralization reaction is the reaction between an acid and a base to form salt and water. So the heat evolved during that particular process is called heat of neutralization. Neutralization reaction is exothermic in nature. So you can see here the reaction between HNO3 and NOH, that is a strong acid and a strong base. And what we have there is exothermic in nature. Then we also have another reaction between HCl, strong acid, and NOH, strong base, giving us NaCl and H2O, also exothermic reaction. So these reactions we have under this place are just showing the heat evolved, and then further proving to us that heat of neutralization is exothermic in nature. Then we have heat of precipitation. It may be defined as the quantity of heat evolved in the precipitation of 1 mole of a sparingly soluble substance on missing dilute solution of suitable electrolyte. Take note of the word sparingly. They are not very soluble. Okay, and here you can see that of our barium ion and sulfuric ion coming together to form a precipitate known as barium sulfate. Then we also have heat of hydration. It may be defined as the quantity of heat evolved or absorbed when 1 mole of an anhydrous or a partially hydrated salt. I remember that when we are looking at the types of salt, we discussed anhydrous salt and then that of hydrated salt. You know, anhydrous salt will not contain water of crystallization, while hydrated salt will contain water of crystallization. So the quantity of heat evolved or absorbed when 1 mole of anhydrous or partially hydrated salt is combined with the required number of moles of water to form a specific hydrated salt. So the heat evolved during that process is called heat of hydration. So here we have, you can see anhydrous, there's copper sulfate reacting with water here to give us copper 2 tetrahydrosulfate 6 pentahydrate. So you can see it's exothermic, and the same thing applicable to calcium chloride. Then we also have heat of fusion. We say it is a change in enthalpy during conversion of 1 mole of a substance from solid to liquid state. From solid to liquid state. Look at it, where you have water. This is in solid state here, going to the liquid state, that is melting. So when you have something of that nature, then you should know what you have is heat of fusion. Then we also have heat of vaporization. It is the change in enthalpy when 1 mole of a